Alright, in today's video we're going to go through a program that counts the amount of digits that exists in a different digit. So what I mean by that is if we input 1 and 123 it returns 1, and if it's 1 and 1123 it should return 2. Likewise should 1 and 111 to 3 return 3. Alright, so you get the point. In order to do this we need a help function. The help function can be called digit, where digit consists of x and y, where both x and y are integers, and we're going to call the values of x and y. We're also going to scan them uh, like so with an EOF, where we print out the function with a backslash n digit xy. So if you follow up with the series, you should be pretty used to this and you should know what this does. Basically we have declared a function digit, and we have declared two values x and y, which are stored in the function, but we print out the function itself. And now the hard part, or more tricky part, is defining what this function does. And for that we're gonna declare two helper functions, which is gonna be int mod and int sum, where sum is equals to 0. And I'm gonna explain to you what it does, because I made a little format. So to start, 1 is equals to x in this case, and 123 is y. So the first thing this program does is that it mods 123 by 10. In that case, this is 3. Then it checks where x is 1 is equals to mod where mod is 3. If this is true, then it's going to add 1. Otherwise, it's going to keep going. So, but if it keeps going normally, then it's just going to do the same thing over and over again, because it's a loop. We're going to, of course, have a loop. So that's why this is going to repeat the same process. Not unless we scale it downwards, and we do that by dividing 123 by 10, which is 12. So in this case we have a new x value, 12. So mod x modded by 10 is 12 modded by 10, which is 2. Now it checks for the second digit. If x where x is 1 is equals to mod where mod is 2, then plus 1, otherwise keep going. Obviously this is not going to keep going, so it's going to scale 12 downwards again by dividing it by 10, which is 1. In the programming world this is 1, not in the mathematical world. However, the mod function is gonna mod x again, the new value of x, which is 1, by 10, which is also 1. This will go in the if statement, where x is 1 and mod is 1. If x is equals to mod, then plus 1. Otherwise, the number that you have given is not found in the integer y. Then it's going to return 0. So to put this code into work, we have to use a while loop where it breaks when y is greater than 0, which you see over here. Because in here you see if x is equals to mod, then 1, and if this is not true, it's gonna keep going, where it's gonna do x equals 1 divided by 10, correct? And this is of course less than 1, and then it breaks the loop. In the loop, you see we're gonna do, first thing we do is we're gonna mod to check for the first digit. So the mod function is gonna be y mod 10. Now we have the first digit. We want to check if the first digit is equals to x. So if x is equals to mod, where mod is the first digit, if this is true, this is where the sum function comes in hand, and then we do sum equals to sum plus 1. Now if this if statement doesn't meet, we're just going to scale downwards again, and we're going to keep going until it meets. Okay? So this makes pretty much sense. If it doesn't, please feel free to ask questions in the comment section. 1, 1 2, 3 returns 0, of course, I forgot to return something. We want to return sum because sum is where the value is stored in. So everything is going to be stored in the sum function in the if case, and then we return sum. Anything else is going to be wrong. My bad. You see, and then 1, 11, 1, 1, and then 111 to 3 should return 3. Alright, you get the point. If you have any questions, feel free to comment down below.